Good morning, everyone. This is John with Simwell, anyLogistix. We're going to get started in just about a minute. Just want to give everyone a little bit more time to join. All right, so welcome everyone. My name is John with Simwell. Thank you for joining How to Evaluate Supply Chain Strategies with anyLogistix. Our goal today is to introduce a step-by-step process that we've used to evaluate real-world supply chain strategies with a special focus on the relationship between strategy and implementation. Now, this is a live webinar, so we encourage you to ask questions when you have them. You'll see a chat window that looks something like this picture. We have a team ready to respond to your questions as you ask them. Although we may wait to respond to some of your questions until the end, or we'll have a Q&A session. If you don't want to submit your question in the chat, you can contact me directly at simwell.io or jsantavi@simwell.io. Today's webinar is hosted by Simwell, a consulting company specializing in simulation and optimization. We're also an anyLogistix distribution partner in North America. My name is John. I'm a partner at Simwell, and I specialize in helping companies answer their most critical what-if questions through simulation. I am joined by my colleague, Alex, a senior supply chain consultant at Simwell. Alex has a breadth of experience spanning 17 years working across the supply chain, and he has a deep understanding of anyLogistix. Today, Alex will show how to evaluate supply chain strategies with the focus on the relationship between strategy and implementation. Now, let's imagine you lead supply chain operations for a global company, and you've identified inefficiencies in the supply chain. Inefficiencies that came from thousands of individual decisions compiled over many years and amplified by volatile demand in 2020. You're in a meeting with your peers, and the group sets an objective to improve those inefficiencies. Specifically, the team is looking to cut costs and improve service level while making sure their network can support growth forecasts over the next 10 years. As the leader of the supply chain, you're in charge of this project. So how do you do it? Where do you even start? Do you talk to your team, open a spreadsheet, review your network, change policies? You know, in reality, it's a complex problem to solve. There's strategic changes to make, as well as tactical and operational changes needed to meet these objectives. If you have an agile, data-driven culture, you'll likely start working with your team to follow your processes and find a way to meet your objectives. If you don't, you're going to take longer and likely make some gut-based decisions along the way. I think about it as a level of agility. How agile are you to respond to questions with data-driven solutions? Supply chain agility is an interesting topic to me. In a supply chain quarterly article from the Council of Supply Chain Management Professionals, agility is described as a company's ability to quickly adjust tactics and operations within its supply chain. Let me say that again because it sounds really simple. Agility is the company's ability to quickly adjust tactics and operations within its supply chain. But in practice, supply chain agility is not simple. First, supply chains are incredibly complex because they touch different departments, customers, and even different companies. In addition, there are a lot of stakeholders in every supply chain. We've listed a few of those here, from analysts, planners, strategic decision makers, operations teams, and more. This means that there are layers and layers of complexity in the supply chain that slow down a company's ability to be agile. So when I think about agility in respect to analytics, I think about how quickly an organization can capture data, model their supply chain, and do analysis to support a change in their supply chain. The reason that's important is because it leads to higher profit and it creates a competitive advantage. anyLogistix is a unique tool because it helps you to create a culture of agility within your supply chain. It allows anyone to build models, whether you're a data scientist, an engineer, or a business analyst. So with anyLogistix, it's easy for teams to work together to analyze a system. Whether you have a senior team sitting around a war room making plans to respond to a drastic change in demand, a network design team improving efficiency, or a cross-functional team planning inventory optimization, anyLogistix helps build agility into analysis and decision-making. Now, this is what we call the pyramid of supply chain problems. On the left, we have the level of detail necessary to solve a problem, and on the right, we have the problems addressed at each level. As we go down through these, we'll see the level of detail increasing at the bottom of the pyramid, along with the types of problems that we can address with anyLogistix. At the top level, we include locations, flows, and linear dependencies to address problems like where to stock products, where to build DCs, and master planning. At this level, we use analytical methods to solve problems. And as we add detail, we move into dynamic simulation. This is why anyLogistix is unique and how it helps you to take an innovative approach to supply chain analytics. For simulation, we add in time, randomness or variability, network processes, resource constraints, and other logic. When we do this, we can start addressing problems like transportation planning, inventory and sourcing policy planning, fleet size optimization, service level and capacity estimation, bullwhip analysis, risk analysis, and resource planning and optimization. Finally, anyLogistix is one of the only tools that allow you to go inside the four walls to understand how the inside influences the outside. Now, at the top of the pyramid, we're looking at mostly strategic and tactical decisions. This is where we do a lot of network design. As we move down towards the bottom or simulation, we get into more tactical and operational decisions. This is how anyLogistix helps you to be more innovative in your approach to anyLogistix. Now, most supply chain tools focus on optimization and solve the top of this pyramid. anyLogistix helps supply chain teams solve all of these problems because of its innovative use of simulation and optimization. I find that most of the supply chain teams that I speak with are intimately familiar with spreadsheets and optimization. They've used these tools to solve network optimization problems, but they aren't as familiar with simulation. At a high level, the difference is that optimization helps you find the best solution, and simulation helps us to understand how a supply chain will perform in the real world. Rather than using generalities, I'd like to give you a real world example. A few years back, I worked on a project to help build a tool for an executive team to better manage their billion-dollar supply chain. When they came to us, they had quarterly planning meetings that they called their war room. In the war room, the leadership team sat down to make a plan for the upcoming quarter. They used a complicated spreadsheet to analyze what-if scenarios. The problem was that every new scenario took time. In fact, it took days or weeks because the spreadsheet guru would go back to their desk, update the spreadsheet, and return with an analysis. Inevitably, there would be more what-if questions, which sent the spreadsheet guru back to their desk, while the team waited days or weeks for analysis. The team came to us looking for a way to improve this process. We built a model of the supply chain that went far beyond a spreadsheet. With this model, we were able to sit in the war room with the executive team, but instead of writing down questions to analyze over the next few days, we simply reran the simulation models, and a few moments later, they had results. This saved the team time and helped them make better decisions faster. But ultimately, it gave them a competitive advantage as they built agility into their supply chain analytics process. If you work at anyLogistix, you can build a culture of agility into your supply chain team too. So when we look at using anyLogistix to solve supply chain problems or to analyze the supply chain, and we typically start with some real-world problem. And the real-world problem, and ideally we could jump straight to a real-world solution. But Often that's not possible, especially in a supply chain, because it's too complex or too expensive or it take too much time. You can't just open up a distribution center and find out if that's helps improve your process. So what we do with anyLogistix is we build a model of a supply chain in a risk-free environment. And we use that model to help us find the right strategy and the right tactical implementation to meet our objectives. In the scenario that we described earlier, that's to improve our service level and cut costs in a way that sets us up to service demand over the next 10 years. So we use that model in this risk-free environment where there's no risk and no cost, and we can run different iterations and run what-if scenarios in a matter of seconds until we find a solution. And we can do this for replenishment and sourcing policies, transportation policies. We can look at inside the four walls, locations, capacities, resources, risk assessment, budgeting, and a whole other list of dozens of applications for this. But we find that solution, and then we implement it into the real world. Now, today, Alex is going to show you how to do this inside of anyLogistix. He's going to start by at a very strategic level of doing a greenfield analysis. Once he creates a greenfield analysis with a single click, he'll move into a network optimization model to help find the most profitable way to service customers. And from network optimization, he'll do one click into a simulation model. And with that simulation model, he'll be able to look at how a supply chain will perform over time and compare different scenarios. And then finally, he'll do a transportation optimization model. And by going through this process, he's going to start at a very strategic level and move through to a tactical implementation to help find the best option or the best way to make a change inside of a supply chain. Ultimately, we'll compare the before and after through what is simulation analysis so we make the right decision for our supply chain. And then we can implement that into the real world. So with that, I'll turn it over to Alex to show how to evaluate supply chain strategies with anyLogistix.
All right, thank you, John. Let me share my screen here.
You back, Alex?
Yeah, I'm not able to share my screen. There you go. Thank you, John. All right, so let's go a little bit overview of the actual GUI here before I start. Well, welcome everybody for today's webinar. First, just kind of take a look at the upper left for those that are not aware or how have used anyLogistix in the past. We have our 4 components: greenfield analysis, we have network optimization, we have simulation and transportation optimization. Here's our scenario panel, basically all the scenarios we have under each one of these components. In this section, we have the experiment section where we run experiments and view our results. And here we have our map editor. Our map editor is where we can make changes, and you can see these changes also on the table editor below. We also have a filtering and a structure frame view, which I'll show you a little bit later on how it looks once we get something more complex in the design. On the lower left, we have our tables. We have our basic tables required to run a GFA. We have additional tables if we want to get more in detail, obviously with more detail, more innovation, more specific problems that we could answer. And then we have in use. These are tables that are potentially we already have records in. This way we could focus on the tables that we are relaying currently and working with. And the bottom right, as I mentioned, our table editor. This is where you could filter, make changes as well after importing your data. So now that I've got a bit of overview of our layout, I'm going to give you a bit of a storyline. So before we start going through each one of these components, let's just say we have a customer that wants to import new products from the supplier in South America as part of a catalog. They currently hold several stores and had a forecasted demand for it. Obviously, they don't have any supply chain set up for this product yet and have decided to build their separate distribution for it. Now, the expectation is to continue to add products from this one supplier. So the supplier's products mostly made up of appliances, furniture, gardening equipment, and lighting. So we need to make sure that we import them here into the US, being that it's coming from South America. So let's begin. Let's start with our GFA. So let's just say our objective right now is to find these optimal locations. What I mean by optimal locations, it's the DC distribution centers that we were going to be distributing from to fulfill our customers' demand. Now the challenge though is that we need to fulfill our service our customers within a 700 mile distance perspective. So we want to make sure that we have that as part of our requirements. And as I said, our plan is to use the GFA experiment to find the number of locations and the right location. So number and location is key here. So let's go ahead. Let's run this one data. As you noticed, we have our certain data already. We have our customer demand and products. So we're going to go ahead and set up our GFA experiment for those locations. First of all, we already have service distance of 700 miles. We are set up for pieces and miles, and we're going to set up our icon as a red icon for our DCs, and we're going to make sure we fulfill our customers. I'm going to go ahead and run this model, and here you see we have 3 prescribed locations to fulfill all our customers. And I just turned on the connections so we could view who's going to fulfill which customers. And here on the bottom left, we could take a little bit more, get more detail statistically. For example, you could view all the lats and longs of these new light locations, demand, coverage, volume, and per distance. So let's just say we liked this result and we want to use it into our network optimization. So let's go ahead and convert this GFA into our NO. Just by right-clicking on it, converting, now you have a network optimization. And you'll notice that all the data from the GFA converted over, which makes it very easy for any analyst to convert back and forth within any of these components, making it very easy and simple to transition. All right, so let's assume that we have now our 3 locations, right? But let's assume the real estate property that we work with, our department, found potential locations in these GFA suggested areas. And we also, through our logistics team, they provided all the potential ports where we could import the product from our supplier, which is located in Brazil. So what I'm going to do here, I'm going to switch over to an identical model that already has all those locations in. So as you take a look, here we have 3 property locations that were considered around the area of the GFA that was prescribed. Here's the other 3 in the area of in Texas that was prescribed, and here in the East Coast around the area that the other location was prescribed. So we have 3 locations potential we could choose from, and then from the logistics team we have all the potential ports available that we can use and make use of importing from our export from Brazil, our supplier. So our objective is to allow the network optimization to solve and provide the most optimal / profitable way to distribute these supplies to our customers. And through that, we had to update, obviously, our product flows, who can send what product, the paths, the processing costs, right? The facility costs, how much the labor would be in exporting or importing into the DCs and the sites, including the customers. So let's show that structure perspective currently, how that looks. So if I connect, if I show the connections we're going to see every potential connection possible, meaning every potential way this product could go from our supplier to our port, to our DCs, and then to our customers. So when we run the model, it's going to provide what's the best process. Let's take a look at it, a much easier view of that. So here, as you see, we have our supplier sending to our ports the product. The port will be sending to the DC and to the customers. And in certain occasions, potentially if it's close enough or worth the cost, it would be sent directly to customers from the ports. Okay, so now one of the constraints though is that we need to allow the solver to select one DC in each one of these regions. In order to do that, we have to use the asset constraint table. Here, we're planning that each one we're allowing the solver to select one DC per region. So for example, here in the West, we're saying that we want to select at least one DC. So the solver will know between these 3 DCs to select one of them. Same thing with the South. We're telling the solver to say, hey, please make sure you only select one DC in the South and then one in the East. And from a port perspective, we just want to use the best one, the best port that makes sense. And so being that we're trying to find the most profitable distribution method for that product, we're also going to plan to use the XPanel experiment, and we're going to run the 5 optimal best solutions. This way we get 5 perspectives and 5 ways to kind of compare to each other to provide to our client. Okay. So here we have our 5 best, most profitable iterations. Let's take a look at our first one. As you take a look, we'll show the connections. Here's the best setup. Here's the second one. You'll notice the port moved. The third one, it's a closer port moved again. And in this one, the DC and a port moved. And the last one, we had the 2 DCs move. So each one of these iterations, obviously, the top being the most profitable, is potentially the one we want to go with. Now, it does not mean that it's the best to service our customers, but it's the most profitable one. Using simulation, we'll be able to identify if that's the case. So let's take a look a little bit now at how that structure looks real quickly. And this is great because now we have an idea how that views. And keep this in mind, you can move this around to replicate kind of the design of how everything looks. So for example, if you want to put something on a document, you can put it there. You could go there, you could put the DC Reno to the left, you could put this one in the upper right. So now you have something that looks more spatial to what it is. And you can put this on any document and make it look more realistic. Okay. So let's compare each one of these results. By looking at our overall stats, you'll be able to see the main difference between each one of these 5. And you'll notice the outbound processing, obviously the labor was a big difference in the inbound and outbound. Also another big difference was the transportation cost. So what we're going to do is we're going to select the top one. Let's go to our results here. What we're going to do, we're going to convert this result. We're going to actually try to work with this in our simulation to find out if this makes sense. So we're going to right click on this one scenario and we're going to convert it to a simulation. And there you go. Now we have our simulation ready to go. So the objective here is to validate the performance of our supply chain based on the prescribed solution. Now, to save time in creating the reporting dashboard, I'm going to go ahead and switch over to this one. That's an identical of this one. Just have it prepared. This way I can save that time. So now we have a prepared dashboard available for everybody to see. Now, the obstacle here is that if our issue is if the customer expectations are being met from a delivery and product availability based on the new selected supply chain. So what we're going to do here, I'm going to go ahead. The plan is to clean up and update the scenario. So you'll notice prior that I had about 20, 18 DCs. Now we're down to 4. So I cleaned this up a little bit. I also removed all the expenses from the facility expenses that of all the sites we're no longer using. This way it makes it easier for everyone to follow. Also, let's just say that the expectation from our customers is 1 to 2 days. So what I did here, I set up the expected lead time to 1.5 days. And we also set a processing time to make it more realistic. As you'll notice, from all sites, from an inbound, outbound perspective, for every cubic meter going in and out, we actually set it up between 1 to 2 minutes per cubic meter. And on average, we put 1.5. Now we're creating some volatile reality. And at the same time, we also did a uniform for our customer, meaning that varies a little bit more wider. It could be anywhere between 1 to 2 minutes. Perfect. So let's go ahead and run this model now that we have everything ready. We have our pieces. We're going to run it by day and miles. And now the great thing about simulation, for those that haven't worked with simulation, is that you can see the animation as it goes in through time. You could fast forward this real quickly and finish it off quickly, or we could slow it down a bit. And you'll notice all the actual distribution of the product as it comes in. And let's take a look at our profit and loss statement. Here's our revenue as it goes up in time, total cost. Here's a breakpoint. As you see, it was around day 70. Now let's take a look at our service level, which is kind of what we're looking to do, right? So here our service level, you'll notice that most are okay. One location that needs work is the New Orleans port. So what this means is that when a customer is making an order, do we have the actual product in our storage? And in many of the cases, most of our DCs we do, which is really good. But obviously our port could have some improvement. And let's look at our ELT service level now. And here, as you can see, there is room for improvement. Estimated lead time is really the expectation of the customer when they're going to have the product. They mentioned between 1 to 2 days, and in certain cases, they're not getting to between 1 and 2 days. So it's definitely going over, especially from the port and from the DC Austin. So as a result, we validated delivery times that they need improvement. So we're going to go ahead and create some milk runs to improve this. So let me go ahead and stop this and save the results. There we go. And what we're going to do now is I'm going to show you the structure just to see once again how it looks. It hasn't changed. It's still the same structure we use in our network optimization. And now we're going to go ahead and convert. We're going to convert our SIM into a TO. And there you have it. We have now a TO model scenario ready to go to run. Now let me go ahead and change the properties on this. I'm going to name it a little bit different. I'm going to name it TO SIM distinguish a little bit the difference. And as I mentioned, during the conversion, we basically have all the data from our simulation. Now, our objective with transportation optimization, aka TO, is to reduce the transportation cost and improve vehicle utilization. And this way we could create those milk runs. Our obstacle, though, is that we're not effectively using our fleet to deliver. So our plan is to run a capacity TO experiment to create these milk runs and potentially export them into our previous simulation to improve that ELT, the estimated lead time. But before we do that, we need to update a few things. Let's take a look at our paths. First, a few things. When we're doing milk runs, we're also going between customer to customer. And previous in our simulation, we weren't doing that. We were going from port to DC, port to customers, and DC to customers. So we need to add customer to customer and then customer back to the DC or the port. So this way we allow the truck to get back to the site. And also we need to also update our cost calculation. Why do we need to do that? Well, we need to also get a mileage perspective, because we also have to include a round robin kind of style where it comes back. So having something that's more fixed or distance based is going to make sense than having something per leg. So let's go ahead. I'm going to delete these rates. I'm going to go ahead and import my new rates. What I'm going to do here is I'm going to select just to import my paths, my new rates, and I'm going to import it into my TO sim network analysis. And voila. Now we have our updated paths with our distances per mile. And just to remind everybody a little bit, since we haven't talked about this, through each one of these locations, from the actual port, you'll notice that we are using, from the port, we're using trucks. Trucks are a little bit heavier or bigger in size, have more space. And then from the DC to the customer, we're using lorries, which are smaller trucks, or have less space, move a little quicker, and so forth. So let's go ahead now. Now that we have our paths and we're ready to go, we're gonna run our capacity TO experiment. Now what we're gonna do here is we're gonna go ahead, I'm gonna select both the lorry and the truck. And I'm gonna customize my period so that it only does like 5 days. So 1, 2, 6. Go. And our travel segment, we're going to make sure it's unlimited. We're going to choose miles, obviously. And that's pretty much it. So what we're going to do here is we could definitely run this model, and it'll probably take me about a minute or two, as I already ran it before. But in order to save everybody time, we're going to go ahead and actually let me quickly run it for you guys so you see. You're probably going to get something like these messages. And you're going to notice a few of these, and it's just letting us know, notifying that certain sites did not use that certain vehicle, and it's providing you a notice of it. So for example, we did not use a lorry from a port, and we did not use a truck from the DCs, and so forth. Since this is going to take some time, guys, I'm going to go ahead and just cancel this out to save you guys time, and transfer over to one that already ran these results. And just keep in mind, these are identical. These are identical, haven't made any changes, so it's still the same data, with the same updated paths and everything. And here are the results. Let's take a look at them. Take a look at this one. So here is one of the milk runs prescribed as optimal. in making sure that we're utilizing our vehicle to the fullest. Here's another one. And let me see what else here. And here's a few direct ones, right? So obviously we can go through all 25 potential. Some of them are direct, so they're not really milk runs, but they're required as we set up a week. Being that these are orders are coming on a weekly basis, this is the milk runs for the week that we can use throughout the year. All right. So let's go ahead and take a look at what we're going to do now. So you're going to notice our simulation. We're going to go back to that. So now that we have our milk runs, and we're going to take a look at our table. Currently, we have no milk runs, so we're going to import them here. So going back to our results, all you would need to do is right-click, export to the scenario, and we're going to import into our sim distribution network analysis. We go back to our sim. Here you go. You're all 17. Now, some of you guys may ask, well, there was 25 in our TO, transportation optimization, but only 17 were actually considered milk runs. So our simulation is going to understand that the rest were only deliveries, direct deliveries, and it's only going to consider milk runs here. So that's why there's only 17. Okay, perfect. Now, what we're going to do though, I'm going to go ahead and copy this over to a simulation, another one, because I want to go ahead and if I go back to this one where I'm going to remove this, because what I want to do is I want to compare one without the milk runs and one with the milk runs. So let me rename this to sim with milk runs. There you go. Now, what I need to do though, now that I've actually added these milk runs, a few things I must do also. I also have to update the paths. So let's take a look at our paths. And as you see, we don't have any rates in between the customers. So we need to, again, update this. And the same thing with the rates. So let's go ahead and remove these. And let's go ahead and import the new paths or the new rates. And we're going to import this one, TO import adjusted path rates. Actually, this. Let me select paths. So import all the data, just the paths. And I'm going to make sure I select the one with milk runs. Excellent. Perfect. There you go, the identical same rates that we had in TO. Okay, so now that we have our milk runs, we have our data, let's go ahead and run this simulation. Make sure it's set up at my pieces level, at the mile, and I'm ready to go. And you could add more realistic pieces to your model, like the number of dock doors, receiving, shipping, or if they're both. You could adjust your fleet size per DC, maybe certain fleet size to make it more realistic. If you have different fleet size in each one of your DCs, you can even add additional data to compare in terms of dock door utilization, fleet utilization. There's over like 100 plus stats that are available that you can use here on in your dashboards. You can even create your own dashboards, rename your dashboards as you see fit. You can rename any of these tables. You could even set it from a table perspective or a graph perspective, and so much more. So let me go ahead and finish this quickly off. And let's take a look at the results. Let me go ahead and save this. All right, first things first, a profit and loss statement. You'll notice that we also had a good revenue, we have profit, and we have a transportation cost. Let's go to our service level, which we're really want to see now. You'll still notice that we haven't really done much about the inventory, so we'll probably still have that service level by products. We'll still have that issue with our source, where you could definitely run a safety stock estimate, and it would allow you to select something more appropriate for the board location, since we're servicing customers from there. And then you'll notice this one, the ELT service level by products. Gradual improvement, not a lot. There was a gradual improvement. So what we're going to do now, we're going to compare this milk run to our previous prior to milk run. So how we do that is we can use a comparison experiment. The comparison experiment is just a way to compare several scenarios. In many cases, you could compare the baseline of your current supply chain to something later on, for example, all the changes you would like to implement, and see how well it would actually work. And this way you could take in consideration if you should implement or not, and show it to the executives before they make any decisions. The great part about comparison is that you get understanding the trade-offs, the risks, the issues, because obviously just because it's very profitable doesn't mean that it's customer centric. So sometimes you want to have a bit of both and align and making sure that it fulfills the organization's alignment to the customer. So let's go ahead and compare. So by going to compare experiment, you can select the one with milk runs, and you're going to select your SIM distribution network analysis, which is our baseline prior to milk runs. We're gonna probably see a bit of a difference. Let's see how much of a difference though. Now let's go ahead and set this up to pieces. Let's set this to mile. There you go. And what we're going to do is we're going to configure those comparisons. And what I mean by this, we're going to be selecting a few things to make our comparisons available. Now, just kind of show you, there's over 113 to select from. So let's select a few like service level, right? ELT, estimate lead time, service level, by product, I want to see those too. I also want to see profit. Let me see what else. I want to see costs. Let's see what kind of costs you can get. Let's get total cost. Let's get transportation cost in there. All right, that's good. And let's get some vehicle information in there. Take a look at. See the average number of vehicles, max number of vehicles we used, shipped vehicles, and let's give vehicle capacity utilization a try and see what happens there. That's it. So let's go ahead and take a look at our results. Excellent. So as you take a look, now we have our future and our current, and you take a look at the differences between them. And this is a good view of what would happen if we were to implement something like this. So take a look at the average number of vehicles we use per day. We went from 27 to 20 with those milk runs on average. Look at our ELT, which we want to improve. We improved by 2%. You know, not ideal. We definitely want a little bit higher. Obviously, we can do much more. We also have max number of vehicles used in a day. In one particular day, we used 100, while the max with the milk run was 55. Big improvement. So we should see that in the transportation costs later on. Here's our profit. Our profit went up about close to a little bit below $1 million. That's good. Our service level should have stayed the same. Our shipped vehicles went almost in half. Amazing. And our total cost also went down a little below $1 million. And you see here, it's mostly because of transportation costs. But look at our vehicle capacity utilization. We went from 52% to 87%. That's phenomenal. So the question is, should we implement this in the real world based on these results? I would suggest yes, because that's $1 million of savings. Okay, so what did we do today? We started from a GFA. We gathered the prescribed number of DCs and locations. We ran a network optimization that included real property locations in those destined areas. We included the ports, all the possible avenues that that product could come in. And we made these requirements to the solver to help find a prescribed solution to optimize our profit. Our simulation reviewed the service levels of our customers to put the focus on the customer in our model. We found that there was an issue with our ELT, and we actually ran a TO to try to increase the ELT service and vehicle utilization through milk runs. And then we used those improvements into a simulation to compare the baseline to the new changes to allow the executives to make an implementation and compare it to its current process. Well, I hope you guys all enjoyed today's model on an end-to-end supply chain solution using all components by means of using conversions. This goes to show that you can collaborate with any different user at any department in your organization to find the most optimal solution and keep everybody involved. Thank you and back to you, John.
Awesome. Thank you very much, Alex. That was fantastic. Just give me 1 second, everyone, and I will reshare my desktop. So anyLogistix is a unique tool that helps improve analytic agility for supply chain teams. It does this by helping you build complex models with a data-driven framework. While in the past, we had to build everything from scratch, and it also includes GIS and demographic data to help go deeper in analysis. Finally, as we saw today, it allows you to create a digital twin of the supply chain so you can quickly run different types of experiments on your supply chain. So to do that, you set up a scenario or a model in anyLogistix and then perform an experiment. And that might include greenfield analysis, network optimization, transportation optimization, risk analysis, inventory optimization, what-if analysis, and even scenario comparisons. And these experiments then give us results, which with a single click can be converted into a new scenario and a new experiment.
Hey,
now,
John.
Yep.
This is Alex. Can you switch over to your PowerPoint? You have the notes.
Yep.
Thank you.
Is that better, Alex?
Not yet. I don't see anything yet.
Is it sharing now?
I see your PowerPoint slide only. I mean, I see your all PowerPoint.
Let's switch back over here. For some reason it switched while we were.
There you go.
That's right?
Yes.
Okay, thank you. So these experiments give us results, which with a single click, we can convert in a new scenario and in new experiments. So this is how you build agility in your supply chain analytics and make enhanced business decisions. So if you're making changes to your supply chain in 2020 and think anyLogistix can help, we have a few ways to get your team started. First, we invite you to schedule a private demo. If you're in North America, you'll schedule with me. And if you're outside North America, you can find your local distribution partner at anyLogistix.com. Must have clicked through that. So just go to anyLogistix.com, click on company and then partners, and you'll find your local partner if you're outside of North America. So if you want to schedule with me, John at Simwell, you can email me at jsantavia@simwell.io. If you want to use this tool quickly, we actually have a public training class scheduled July 28th to the 31st. This is a great way to learn how to use the tool and even to evaluate the tool. We encourage you to invite others to see how anyLogistix can be used with your team. In the 4-day course, you will learn how to solve end-to-end business problems in your supply chain with anyLogistix. Again, Feel free to email me at jsantavia@simwell.io if you'd like to join, and I can send you a link. Finally, we host private training classes. This is a great option if you're training 5 or more people from your team and want customized attention. Now, again, email me at jsantavia@simwell.io to set up a time for a private training. Now, thank you to everyone that joined this webinar. If you found it useful and want to learn more, please contact me. My email is here and our website, www.simwell.io. You can download anyLogistix at anyLogistix.com. And thank you all very much. Now, we've reserved time for Q&A. We had some fantastic questions come in during this. Please feel free to send more and I'll be answering them. So I made a list of a couple of the questions that came through. So we had a few people ask about limitations in data size. There are no real limitations in anyLogistix. Limitations would be more on the processing power of your computer. But in best practice with any type of modeling, there's always different ways to approach large data sets. So if you have any limitations or concerns, feel free to email and we'll be able to give you some guidance or recommendations on how you approach that. Another question was, can you use actual roads in your analysis with anyLogistix? The answer is yes. anyLogistix integrates, or GIS is integrated into anyLogistix. So you can actually do GFA and network optimization with real roads. And that's a very, very powerful thing. And so it can help you find the optimal location for DC down to the street level. So that's a really, really neat, powerful thing with the tool. And that helps you to save a lot of time because it automatically calculates distances from one location to another. Someone asked about unit conversions, and unit conversions are very simple in anyLogistix. You can set that up before you start a project, so you don't have to think about it again, or as you go along, if things are changing, you can do conversions right in the tool. And there's some places there are data tables to do that, or ways to do that in the app. Another question that just came in is, how does the tool show you what's better in terms of cost by comparing scenarios? And as you build your models, you're going to add cost to your DCs, cost to your transportation costs. You can add any cost across the operation. And so whenever it does a simulation model, it will calculate those costs and for scenario 1 versus scenario 2 versus scenario 3. So when you look at your comparison, you can see overall profitability, and you can also see those costs broken down by their individual level. So whether that's transportation or the DC or what have you. Go through, see it. For GIS and demographic data, would the anyLogistix user have to subscribe to third-party data provider services? The answer is no. GIS is integrated right into the tool, so you don't have to subscribe to anything for that. How can we add business rules, such as when stock is limited at a DC, and which customer order to fulfill, and other types of business rules? So you can add any policies or business rules into anyLogistix, and you do that through a data table. We didn't go too much into the how, and if you want to see more of that, there's a couple ways to do it. You could schedule a private demo with us. Again, just shoot me an email. Or we have a training class coming up at the end of July, where we will. It's four almost full days where we go into everything about the tool. We do greenfield analysis, network optimization, simulation, inside the 4 walls, transportation optimization. We show how to build complexity into the model, or let's say capture complexity of your supply chain in the model. So that's all possible and relatively simple with this tool. Let's get a few more minutes left. Let's see what other questions we can find here. How specific do the data templates have to be? So in anyLogistix, there are data tables that you use to import information. So for each type of experiment, greenfield analysis, network optimization, simulation, transportation optimization, there is what we call a basic table set. And you have to have all of those data tables in order to run one of those experiments. There's not a ton of them, but it'll be just essentially the bare minimum to do that experiment. And then there are additional tables, and in those additional tables you can add more detail and more information, more policies, more everything, and that's where you're starting to capture the real world complexity of your model. So there is a basic requirement on the data side, and then there's I won't say endless, but almost an endless amount of additional data that you can add in depending on what you need to do to make better decisions with your team. Another question is, how can we integrate ALX with ERP for transportation planning purposes, or is ALX focused on high-level planning only? So that's a fantastic question. ALX is not focused on high-level planning only. It's a great tool from that strategic and tactical planning side, but then you can, once you build that digital twin of your supply chain, because that's what you're really doing, you can connect it to your systems, and you can automate data pools into anyLogistix to help make decisions, whether that's on a daily basis or a weekly basis or monthly or what have you. So you can use this digital twin that you build in anyLogistix, connect it to your other systems to pull data, and then automate runs with that to help with different types of decisions. What about inventory cost in the simulations? That is all included in the data tables, or easy to add in the data tables. Okay, so I think we got through all of the questions. Kind of hard for me to see, so but at the end we'll be able to see all the questions, and we'll try to email answers that we did not get to. If you have any questions or more confidential, private questions about a project or how to apply this, again, feel free to email me. Download anyLogistix at anyLogistix.com. And this is John at Simwell, and on behalf of Alex and our whole team, we really appreciate your time today joining. We appreciate your interest in anyLogistix, and we hope to hear from you soon. Thank you. Bye.